Hello, everyone. Welcome to our project page on ResearchGate. I know it is a little bit overdue, but I'm here to give the final update for our project entitled Effects of Climate and Land Use Changes on Fish Catches Across Lakes at a Global Scale. I am Yu-Chun. This is one of my postdoc projects at Michigan State University. If you have any question, you can reach me through Twitter or send me an email. First, I want to acknowledge my 30 co-authors from 19 different countries. Without them, I won't be able to present this project in front of you here. Second, the main product of this project is a paper published on Nature Communications. As I am going to skip a lot of details in this presentation, I am giving the link to the paper here. If you want to know more details, please read the paper. You will hear me saying this many times throughout the presentation. For the science communication purpose, I also wrote a blog post for the nature, ecology, and evolution community. It is one of the behind the paper stories. I personally think it is a funnier and easier read. I am also giving the link to the story here. For today's presentation, I will first give an introduction about why we are motivated to start this project. Then I will briefly talk about how we carried out this research. Next, I will give high-level summaries for our methods and results. Finally, I will give our main take-home messages. So, why were we so motivated to start this project? In fact, we started this project back to 2016. At that time, we already knew the importance of lake fisheries well enough. For example, they support livelihood, food, and nutrients to the most impoverished communities around the world. We also knew lake ecosystems are already stressed by human activities. As you can see these photos provided by my co-authors at the bottom of this slide, these activities can all affect water quality. Meanwhile, United States Geological Survey, better known as USGS, wanted to support studies on effects of climate change on inland fisheries at a global scale. Surely we were interested, but every time you want to start a global scale project, you just cannot stop yourself saying, "But we don't have enough data." Well, I said, I have a great idea. Maybe it will work. Then we wrote a research proposal, got funding, and started this project. By the way, when I say we in these and the previous slides, it means Mark Rogers, Bob Arnell, and myself. You can see one of our photos here. Mark and Bob hired me as a postdoc, and we did quite a lot of work before the other co-authors joined this project. The goal of this project is to assess effects of climate and land use changes on fish catches across lakes at a global scale. Our general approach is to analyze historical data between 1970 and 2014 for as many different lakes as feasible. I highlighted historical because climate and land use have been changing quite rapidly in past 50 years. They should have affected lake fisheries in some ways. And if our model is good enough, we should be able to detect their effects. I also highlighted different. It is because we cannot study all lakes on the Earth. However, if we can include many different types of lakes in this study, we can possibly draw useful management implications from our result. Our basic hypothesis is that climate and land use changes affected lake environment, which in turn affected fish catch. Based on this basic hypothesis, we identified data needs. Based on the identified data needs, we started to find data by sending out emails, using our research networks, and going to conferences. You can see one of my presentation slides here, which was used in World Fisheries Congress in 2016. Long story short, ta-da! We built a team and got data for 31 lakes, with roughly equal number of lakes in Africa, Asia, Europe, and the Americas. From now on, when I say we, it means all 31 co-authors. Now, it is time to introduce our analytical methods. The core of our analysis is the Bayesian networks model. We choose to use this modeling approach because it can increase the statistical power of our analysis. Why is that? How does it work? I don't have time to cover these details, so please read our paper about that. As shown in this figure, our Bayesian networks model was developed by combining our research hypotheses and available data at a global scale. It represents that climate and land use drivers, which include air temperature, precipitation, and agricultural land use in this study, will only affect lake environmental variables, which include water temperature, water level, and chlorophyll. Here we use the chlorophyll as a proxy of primary production. Finally, we have lake environmental variables together with fish stocking and fishing effort control fish catch. In total, we conducted 3 analyses. First, we investigated how climate and land use changes affected fish catches. Then we assessed the changes in each climate and land use drivers associated with a substantial 25% decrease in fish catches across lakes. Finally, we conducted a correlation analysis to identify lakes where fish catches are vulnerable to climate and land use changes. Here come the results. First, this figure shows how a climate or land use driver affected fish catches based on Bayesian networks model coefficients. Plus sign here means effects were mostly positive across the 31 lakes. Minus sign means effects were mostly negative. And the plus and minus sign means effects could be either positive or negative. As you can find here, effects of a climate or land use driver on lake environment can be consistent in direction across lakes, but not always. However, effects of a lake environmental variable on fish catch seems like always can be either positive or negative. As a result, climate and land use changes can result in either positive or negative effects on fish catches across lakes. For this part of our results, I am going to show you 3 very complicated figures and talk about the big picture messages from them. As you can see, I don't think it is very possible for anyone to understand everything in these figures in such a short time. Therefore, once again, if you want to know the details, please read our paper. This is a simulation analysis to investigate how much change in a climate or land use driver could result in a substantial 25% decrease in fish catch in each lake. In this figure, the driver is air temperature, and let's start with the top left panel. Each bar here represents simulated median change in air temperature in a lake associated with a 25% decrease in fish catch. For lakes above the upper dashed line, effects of air temperature on fish catch were positive, because decreases in air temperature led to decreases in fish catch. For lakes in the middle of the two dashed lines, effects of air temperature on fish catch could be either positive or negative, as the arrow bars crossed zero. For lakes below the lower dashed line, effects of air temperature on fish catch were negative because increases in air temperature led to decreases in catch. Now we go back to the figure. The top right part of this figure shows how changes in air temperature affected lake environment. As you can see here, this part of the figure shows effects of air temperature on water temperature, effects of air temperature on water level, and the effects of air temperature on chlorophyll. Then, the bottom left part of this figure shows how changes in lake environment affected fish catch. As you can see, here we show how each of the three lake environmental variables affected fish catch. Finally, in this figure, we have a graphic summary. This summary shows how air temperature affected fish catches across lakes. The width of each arrow qualitatively represents the strength of effects. So, look at this figure again. What does it all mean? The big picture message here is that changes in air temperature could have either positive or negative effects on fish catches, and the effects could be mostly mediated through changes in water temperature. Now we look at the results for simulated changes in precipitation associated with a 25% catch decrease across lakes. The big picture message here is similar. We also found that changes in precipitation could have either positive or negative effects on fish catches. However, the effects could be mediated through either changes in chlorophyll or changes in water level. Once again, we have a similar big picture message after looking at the results for simulated changes in agricultural land use associated with the 25% catch decrease across lakes. We found that changes in agricultural land use could have either positive or negative effects on fish catches, and the effects could be mostly mediated through changes in chlorophyll. Our final analysis was to identify characteristics of lakes where fish catches are vulnerable to climate and land use changes. We define a lake is more vulnerable if less changes in climate or land use can result in the same, but a substantial decrease in fish catch. We conducted a correlation analysis between median changes in climate and land use drivers associated with a 25% decrease in fish catch, which were obtained from previous analysis, and 4 lake characteristics, including access to clean water, coastal population density, average depth, and a littoral zone area, which was measured by Shoreline Development Index. The results were somewhat surprising. We found that access to clean water is the only characteristic that is positively correlated with the magnitude of changes associated with a 25% decrease in fish catch for all 3 climate and land use drivers in this study. This suggests that the more access to clean water, the more changes in climate and land use could be needed to result in a substantial decrease in fish catch, and thus, the fish catch could be less vulnerable. With all these results, we have some take-home messages. First, fish catches can respond either positively or negatively to climate and land use changes. This is mainly because the same change in a lake environmental variable could result in increases in fish catch in one lake but decreases in another. However, reduction in fish catch was less likely to occur if a lake is located in a region with greater access to clean water. The most importantly, this suggests the adequate investments for water quality protection and water use efficiency can provide additional benefits to lake fisheries and food security. Finally, I want to say thank you to United States Geological Survey for funding support. I also want to say thank you to Alexis and Irene for their help at the beginning of this project. I also want to say thank you to Craig for reviewing an earlier draft of our final paper. The end.